Okay, in this short video, I'm going to walk you through the charging and discharging of a capacitor. Right, now I've got the electronics board set up here. As you can see, here's the capacitor here. We've got it's a 2200 microfarad capacitor. Here's our power supply. Now I've got this set to 5 volts DC. As you can see, there's two circuits here. There's a charging circuit and a discharging circuit. Now the way I'm going to flip between the two is using this short flying lead here. So that will be charging. Okay, as we can see, the conventional current's flowing positive into the capacitor and back to negative there. Okay, so electrons are leaving here, go onto the bottom plate. Okay, they're pushing electrons off the top plate, which go back to the positive terminal of the power supply. Okay, so we have negative on the bottom and positive on the top. That's how the charging takes place. Right, to discharge, we just disconnect it and we put the flying lead over there. Now, when we discharge capacitors, we usually discharge through a component. Now I think you can see there we've got a 100 ohm resistor. So what's going to happen? Well, conventional current is going to flow around through and back into the other side of the plate. So basically we're going to have, when the capacitor is discharged, an equal amount of charge on either plate. So it's going to be fully discharged then. Right, let's get the show on the road. So basically, I think last lesson I've shown you, so we've got a voltmeter here, so we've got a multimeter that's going to be sort of connected across the capacitor at all times, so that's going to tell us the voltage across the capacitor. Okay. At the moment we can see it's on 0, so that's going to be fully discharged, and if we charge it, that's going to jump up quite quickly to the 5 volts. Now the reason why it charged very quickly is obviously we're not charging it through anything, so it's reached its full capacity very quickly. And if we discharge it through the 100 ohm resistor, we should see the voltage drop quite quickly. Okay. Now get it charged up again. Right, if we charge it through a bigger resistor, so let's go with, read that, 1 kilo ohm, so that's 1000 ohms. We should notice that it discharges more slowly, but again the voltage drops until it reaches 0. Okay, like we discussed last lesson, it will drop rapidly at first and then it will drop less rapidly as time goes on. Okay, that's a very important feature of capacitors. Okay, right, now we are going to be investigating using the data loggers today then, and we could use a multimeter. Okay, we could use a multimeter to measure the current as well. Okay, I'll just quickly show you that. Alright, now, so let's look at the charging. So if we put the multimeter in here, okay, if we put the multimeter in here, that's going to be measuring the current as it's charging. Right, so let's discharge the capacitor first. So that's just short circuits the capacitor. Okay, so we are ready to charge. Now let's charge it a bit more slowly. If we charge it just without a charging resistor, okay, the voltage will jump up to 5 volts very quickly. We'll get a big current, but that current will drop to 0. The reason why the current's dropped to 0 is because we're fully charged, so there's no more charge can go onto the capacitor. Okay, but if we charge through the 1 kilo ohm resistor, okay, so let's just discharge the capacitor. Now if we charge it through the 1 kilo ohm resistor, we can see the voltage jump up more slowly, but the current starts maximum and the current drops to 0. Okay, so the current's now dropped to 0 because the capacitor is fully charged. Right, let's dispense with the multimeters, because what we're going to use now, I want to record the data using some data loggers. Now I've got these fellas here. You've got the Pasco wireless voltmeter and wireless ammeter. I'm going to use those instead because we can record the data in real time and plot it on a graph. Okay, so there's our current. Okay. Wireless ammeter, and here is our wireless voltmeter. Right, going to use the Pasco SparkView software. Okay. Now, let's start at the beginning. Let's fully discharge the capacitor. Now when we're ready to charge, okay, when we're ready to charge, I'm going to press play. So press start here and I'll start recording the data in real time. I don't like those colours. Let's try again. That's better. Right, so here we go. So we're now charging through a 1 kilo ohm resistor. Right, as we saw with the voltmeters, with the multimeters, okay, let's just rescale that. As you saw with the multimeter, voltage jumped up rapidly at first and then plateaued out. Current started high and then dropped rapidly at first until it dropped to 0. Okay, so some nice charging curves for the capacitor there. Okay. Now let's just do one last thing. Okay, what I'm going to do is let's replace the 1 kilo. Okay, let's go for 270. What we're going to see with the 270. Right, discharge the capacitor first. Okay. And when we're ready, that'll do. Right, so let's start charging now. So same shape, okay, it's exactly the same shape. However, what do we notice that's different? Okay. The jump up in voltage is more rapid. Okay, it reaches the maximum charge voltage very much more quickly. But the current, this is interesting. The current here starts much higher, but drops more rapidly. Okay. Now what you should notice there. Okay, what you should notice is the area. The area under these two curves should be the same. Okay, the total area under, because the total area is going to correspond to the total amount of charge that's stored on the plates. But the voltage curves, they both reach their maximum voltage. Okay, they both reach maximum voltage, but with the 270 ohm, it does it much more quickly. Okay. Right, so they have charging curves. Okay, so they are the characteristic charging curves. What about discharging curves? Right, what I'm going to do now, the voltmeter stays in the same place. Okay. but I want to. So let's discharge it through the 270. Okay, let's discharge it through the 270. We'll leave the voltmeter in the same place, but I want the ammeter to measure the current in the discharge circuit. So that's going to go there, like that. Right. So always start with the capacitor being totally discharged. Okay. Now, because this is we want discharging now, so we're going to start with it fully charged. Okay. Now that will, as long as we put that there, as long as we complete the charging circuit, because there's no resistor here, that's going to charge that instantly. So we should have capacitor's now charged to 5 volts. Right, now discharging it, so let's record the data in real time. Let's record both the voltage across and the current through the discharge circuit. Okay. Right, as we can see, voltage is at 5 volts. Current is at 0. Let's just 0 that. Okay, so current's at 0, but voltage across the capacitor is at 5 volts. Now, if we start discharging, we see both drop exponentially to 0. Okay, pretty good. Right, one last thing. I've got a range of resistors here, but let's change. Let's go with the 1 kilo ohm. Okay, so let's go with the 1000 ohms. Right, let's start with it fully charged again. Okay, so we'll start with the capacitor charged to 5 volts. Now, so around about 20 seconds. So again, voltage starts at 5 volts, current starts at 0. Now what we're expecting to see with the discharge now, before we discharged through 270 ohm resistor, we're now discharging through 1000 ohms. Any predictions? Okay, right, so because we have a higher resistance, we've got a higher resistance, so we have a more gradual discharge. Okay, much more gradual discharge. But another thing you should notice is the discharge current is lower, isn't it? So if I just put them both together, so the discharge current is lower. Yeah, so they both drop from the same maximum voltage, but with the 1000 ohm, we had a lower overall current, but that current flowed for a longer time. So again, with the charging curve, the 2 charging curves I showed you, the area underneath these 2 should be the same, because that's the total charge stored in the capacitor. Okay, well there you have it. There is the charging and discharging curves for a capacitor. Now, just a quick explanation on why we get the characteristic exponential nature of the charging and discharging curves. So if we look at these 2 curves, so forget about charge for now, but if we were to plot voltage and current against time, like we just did with the data logging software, we see this, don't we? Okay, so we see voltage. So for charging, we see voltage rise rapidly and then plateau out, but we see current start at a high value and drop. Okay, and then plateau out as it approaches 0, right? But with discharging, we see both voltage and current exponentially decay, don't we? Okay, but what's the reason for that? Now, if we think about what's happening when we charge a capacitor. Okay, so there's our capacitor. I've drawn the battery that way, so which plate is going to be negative? Right, the top plate is going to be negative, so electrons are going to be deposited onto the top plate. Right, now right at the start, okay, we've got two parallel plates. They've got 3 electrons, but we want to put more electrons onto the top plate. So, but at the start, because the top plate is neutral, it's very easy to add electrons right away. Okay, so that's why the current is high at the start. That's why the voltage rises rapidly at the start, because at the start it's very easy to get electrons on. But as time goes on, when more electrons are on the top plate, it becomes more difficult to put more on, because there's a pushback. The electrons that are there already push back on the electrons you're trying to push back put onto the plate. Okay, so as time goes on, the plates become full up. Okay, so that voltage there, that power supply, cannot put any more electrons onto the capacitor. Cannot put any more electrons onto the top plate, because the pushback from the electrons that are there, the extra electrons that are there, the pushback is too much. Okay, so just to recap. Okay, at first, the first few electrons go on really easily, so they go on quickly, but then it slows down until it stops. Okay, and that is why we have the exponential nature of the curves. Right, so there is a quick run through of the charging and discharging curves of a capacitor with electronics board and data loggers. Right, thank you very much.